Now, it's my pleasure to welcome you to what is quite a contentious debate, what we don't know about CO2. And with our panel today, we've got Michael McIntyre, Bob Carter, our chair, Gabrielle Walker, and Richard Corfield. So if you please join me in welcoming them.
Thanks everybody and welcome. My name is Gabrielle Walker and my background is in climate science. I wrote a book with a hot topic about climate change in which I tried to give a dispassionate view of what we know and what we don't know, and so that's partly my qualification for being here. I'd like to say that when I was here in Hay last year, I was talking about Antarctica, and I was in a tent where it was freezing cold and the wind was really whistling, so that was very appropriate. So I'm glad that Hay is obliging again, and now we're going to talk about climate change and global warming. We've got a lovely sunny day. I'm very happy to be having this discussion because I think a lot of times the whole question of climate change, if you try and make it into something like a panel debate, then it can just become a bit kind of name-calling and not very rich or deep in trying to understand where we actually are. But I think there are some things that we clearly know about CO2 and some things that we clearly don't. And a grown-up conversation is about understanding that and working out what we need to do about it. And I trust my panelists are all ready for that kind of grown-up conversation. So we do know that CO2 levels are rising. It's much harder to understand what the impact of that might be. And also, there's a lot of apocalyptic talk. The end of the world is nigh and some sort of doomsaying. And does that really help us or does that hinder us? Is it necessary to sort of shake people awake? Or is it just making people put their hands over their ears and ignore the problem even more? So those are some of the things that we're going to discuss today. I'll just briefly mention the format. Each of the speakers is going to have a very brief opportunity to sort of state their case, and then we'll have a discussion among the panel here, and then we'll open up to the audience. And we have an hour to try and cover everything we know and everything we don't know about carbon dioxide, starting now. So our first speaker is Michael McIntyre, who is a very distinguished atmospheric physicist and emeritus professor at Cambridge. He's focused on the hole in the ozone layer and some of the deepest connections between mathematics and music. We'll be talking about some of that tomorrow as well. So, Michael, over to you.
Yes, it'll be completely different tomorrow at 2 o'clock. Today, just a quick idea of where I'm coming from. I'm just a humble scientist who can't do politics. Politics and big money are beyond me. I want to avoid it. I want to stick to the science. Now, science is never about absolute truth or absolute falsehood. Science is always about levels of confidence, about balance of probabilities. I worked on the, as Gabriel said, ozone hole problem and helped to build a very high level of confidence that we know what's going on with the ozone hole, and I was elected as a Fellow of the Royal Society for that work. Now, the ozone hole problem is hugely complicated. For instance, it involves a huge range of timescales, from femtoseconds, million billionths of a second, all the way out to days, years, and very many decades. It involves greenhouse gases and heat radiation. It involves chemistry and photochemistry, of course, and it also involves fluid dynamics, hugely complicated air motion, carrying chemicals from one place to another and mixing them. Yet, despite all that, we were able to penetrate the web of complexity and cut through to what's simple, understandable, and evidence-based. The level of confidence indeed became so high with very many cross-checks that the big money had to drop its campaign to discredit us. Now, what about climate and carbon dioxide? Carbon dioxide, CO2 if you will. My own position is independent of IPCC and official climate funding. I've never received any climate science funding. The climate system is even more complex than the ozone hole. The ozone layer is just a small part of the climate system. And in the climate system there's an even larger range of timescales, out to tens, hundreds, thousands and tens of thousands of years at least. But can we spot anything that's nevertheless simple, as we did with the ozone hole? And I think the answer is yes. And by the way, there's more about this on my website, which you can find by Googling, quote, lucidity principles, unquote. Now, to make progress with any problem of this kind of complexity, we need good analogies and metaphors. There's a deep philosophical point here. All thinking is in metaphors, but some metaphors are better than others. I've looked at the evidence for past climate change, and I've considered what we know with high confidence about the chemistry and physics of carbon dioxide, CO2, and water vapour, and the other greenhouse gases. And I would argue that a good metaphor for the climate system is to liken it to a complex and very noisy electrical circuit with many components responding on many different timescales. You picture this circuit as a bunch of noisy oscillators, noisy nonlinear oscillators and amplifiers strung together in a complex network. Now here's the key point. Some parts of this circuit are more sensitive than others, just like an ordinary electronic amplifier. And if you start injecting currents into different parts of the circuit, the response depends on which parts. Injecting into the input circuitry has a much bigger effect than injecting into the power amplification circuitry. Now in the real climate system, there's hard evidence from past climates and from the well-established properties of CO2 and other greenhouse gases that the CO2 part of the system, technically I should say the carbon cycle part of the system, is one of the most sensitive parts. The CO2 part is like the input circuitry of an electronic amplifier. And the water vapour part is entirely different. It's like the power amplification circuit, something that responds to the input. And there's a lot of jargon about feedback and whatnot, which I don't want to introduce. But we know the typical amplitudes in the carbon dioxide circuitry of the climate system in its present state and for the past 800,000 years, roughly. Atmospheric carbon dioxide has a natural range of variation of pretty close to 100 parts per billion by volume. And we humans have now injected more than another 100 parts per million by volume, and we're going to inject several times that before we're finished. So two final points. First, the amplified response to the extra carbon dioxide injected by humans will be huge sooner or later, and my experience with complex systems supports that statement with high confidence. In brief, it depends on the paleoclimate record and on physical chemical properties of carbon dioxide infrared radiation, which are well known. Second point, there are also huge uncertainties, almost entirely about the timings and the precise nature of the coming changes and the precise order of events and the precise effects of the geoengineering that might then be undertaken. And there I agree with Bob and with Freeman Dyson, and I think with Richard Corfield probably, that big climate models aren't up to the job. But to repeat my bottom line, we can say with high confidence that the extra CO2 from fossil fuel burning will have huge effects over the coming decades and centuries, and indeed millennia. And one of these, by the way, will almost certainly be tens of metres of sea level rise. Now that's my judgment from insight into complex systems. But it's not an apocalyptic thing, it's not the end of life on Earth or even of humans. And I like Richard Branson's take. It's a huge business opportunity for those who are smart and prepared to think long. Thank you.
So, what do we know about CO2? It has an effect on climate. It's a particularly sensitive part of the whole system, so that relatively small changes can make a big difference. That's something that we know, says Michael. We know that it will have very big effects, probably sea level rise. We don't know exactly the levels, we don't know the order of events, and we don't know the effects that our tinkering might have. We do know that big climate models aren't up to the job, but I think we might need to talk a little bit more about what that job might be. We do know that it's not going to be the end of life on Earth, and we do know that it's a huge business opportunity. So that's some quite concrete things that we know or we don't know. Okay, so now your opportunity, Bob. Bob Carter is a paleontologist and a geologist, and actually I believe was at Cambridge with Michael. and he's Chief Scientific Advisor for the International Climate Science Commission, and his publications include Climate, the Counter-Consensus. So Bob, would you like to give us a bit of counter-consensus?
Thank you, Gabrielle. Addressing the question, what do we know about CO2, I'd like to make 4 points, which in part overlap with some that Michael's made. The first is that it is a greenhouse gas. There's no question about that. The physics is quite straightforward. And if more is put into the atmosphere, then prima facie it will cause some extra warming. Other things being equal. However, other things are not equal. And when we put extra carbon dioxide into the atmosphere, it gets a little bit warmer, and in principle that then evaporates some extra water from the ocean basins. As Michael's pointed out, water vapour is a very powerful greenhouse gas, so that extra water vapour causes a little bit more warming, so you get an amplification of warming. Also, however, if you have more water vapour, you have more low-level clouds, and clouds are the climate system's thermostat for cooling, because they bounce the radiation back to space, incoming solar radiation. So it's complicated, but in principle, it's a greenhouse gas. More into the atmosphere, there will be some warming. The debate is about how much, once you take all those other things into account. Second point about carbon dioxide is that it is, through plants, the basis for almost all our planetary biodiversity. Now, the biologists amongst you will know about methanogenic and aerobic biological systems. They are there and they're not unimportant. But the great diversity of life on the planet is largely sustained within the system of photosynthesis, plants, and then other animals eating plants, and so on and so forth, the food chain. So second point about carbon dioxide is it's the basis for most of our planetary biodiversity. Third point, and this may surprise some of you, is that at pre-industrial levels, carbon dioxide in the atmosphere was at almost catastrophically low levels. Pre-industrial level was about 180 parts per million.
That's the Ice Age.
Yes, that's 20,000 years ago in the Ice Age. And if we take that down to 150 parts per million, the plant physiologists will tell you that most photosynthesizing plants fall over. So we came within an ace of a collapse of the planetary ecosystems during the last glaciation and indeed during the preceding glaciations. It is a great relief that when it warmed up into our present interglacial and other interglacials, the carbon dioxide goes up about 100 ppm, so it goes to 280 ppm, which was the pre-industrial level that we inherited. Michael's just pointed out, we've now increased that to 380 ppm.
400
now, or if you like, 400. So the question is, should I be alarmed about that? And the answer is no. That represents planetary carbon dioxide starvation. If you go back to the start of organised multicellular life, to the beginning of the Cambrian period, you find that the amount of carbon dioxide in the atmosphere was 15 times today's level, at 4,000 to 5,000 parts per million. And we can trace the diversity of metazoan fossils in life through 500 million years since the Cambrian, and we find organisms similar to today in their physiology and so on, as far as we can discern that, and they were living in oceans and with an atmosphere within the bounds of the modern oceans and atmosphere. Not exactly the same, there were geochemical differences and physical differences, but similar. So the plants and animals we have on the planet today are descended from these early descents that were living, quite happily apparently, in an atmosphere of 15 times today's present level. So even doubling the carbon dioxide from 280 parts per million to 560, which is what is so feared by many environmentalists, still produces a planet where most plants are operating below their physiological optimum. And it's not for accidental reasons that commercial tomato growers grow their tomatoes in greenhouses that have 1,000 parts per million carbon dioxide seeded into them. So even if we double and then double again carbon dioxide by the criteria of the ancient past, we still will have a carbon dioxide starved atmosphere. And my fourth point is that increases like that, up to 1,000 ppm or 2,000 ppm, will actually provide benefits. And the first benefit is that under double CO2, most plants grow better, but specifically cereal crops grow better. And the agronomical studies show that, for example, with cereals, on average, if you double the CO2, you increase their productivity by about 60%. Secondly, we've referred to the fact that we've put 100 ppm extra into the atmosphere already, and a small part of that extra carbon dioxide is plant food, so it causes plant fertilisation. And in the southern Sahara fringe, the so-called Sahel region in Africa, between 1989 and 2009, so that's 20 years, about 300,000 square kilometres of new vegetation grew. This is a greening of the planet, and it's produced by, in part, fertilisation by carbon dioxide in the atmosphere. Third advantage of carbon dioxide has is it warms the atmosphere. There are some very good solar physicists at the moment that are pointing out the solar physics we are seeing at the moment suggests we may be getting 20 or 30 years of quite significant cooling. And in that context, a little bit of carbon dioxide can't do any harm. So my conclusion, Madam Chairman, is that carbon dioxide is an environmental benefit.
Okay, thank you very much. So, let's just run through those then. So carbon dioxide, definitely greenhouse gas, definitely causes warming. We do know that, but we don't know very much. It's a basis for almost all planetary biodiversity. It's actually very necessary for life on Earth, for most life on Earth, and we were close in the lowest CO2 levels that we've seen in the last few 100,000 years, close to CO2 starvation. Benefits, doubled CO2, plants grow better, especially cereals, so I'll come back to that in a little bit. And also we can stave off some of the potential cooling that might come from the cooling of the sun. So finally, we have Richard Corfield, and Richard is a scientist, he's a writer, and he's a regular panellist on Hay-on-Wye, it says here, and also has written Architects of Eternity and Lives of the Planets, and he's going to give us his short 5-minute perspective.
Thank you. It might actually be shorter than 5 minutes. I'm a geologist as well, and I trained at Cambridge with a guy called Nick Shackleton, who ended up being Professor Sir Nick Shackleton, FRS, and he was awarded the Crayfield Prize for Geology, which is the equivalent of the Nobel Prize in the geological community. And I was there when he and a man called Nick McIntyre established that carbon dioxide changes lag temperature changes in the geological record of ice ages. They used a core called V1930, which came from the Equatorial Pacific, and it was quite clear that by measuring carbon isotope gradients, which is something I don't think we necessarily need to get into, but if you'd be kind enough to take my word that it is a measure for the partial pressure of carbon dioxide in the atmosphere in the geological past, this measure enables us to measure CO2 for the past, certainly 180,000 years. Actually, Nick, before he died, measured it back to about 2.7 million years, which puts us back beyond the Pleistocene boundary into the Pliocene. So, the point of all this is that put that together with our undeniable ability to measure temperature in ocean pools, which we can do using oxygen isotopes, so we're using oxygen and carbon isotopes, one to measure carbon dioxide, one to measure temperature. It is quite clear that carbon dioxide changes influence the Earth's temperature and geological timescales. I mean, it's just a fact. Now,
lags or leads?
Sorry?
Lags or leads?
You just said influences, was the key point there.
I said influences.
Lags.
Anyhow, the history of the Earth is 4.5 billion years of planetary evolution. Life appeared on this planet 3.8 billion years ago, and carbon dioxide, as Robert has said, has varied widely throughout that time. In the Cretaceous, which I know a little bit about, which was broadly 160 to 65 million years before the present, ended with the death of the dinosaurs. Carbon dioxide levels were 8 times higher than they are today. So that's 24,000 parts per ppm, 24 parts per thousand, as opposed to whatever it is today, 400 parts per million or so. So dinosaurs were very happy under that regime, and then they became extinct for completely unrelated reasons, which was the arrival of an asteroid at the Cretaceous Tertiary boundary. And this, of course, allowed mammals to evolve into the niches, the ecological niches which were left behind by the dinosaurs. And during that time, the Earth has cooled from the beginning of the Cenozoic 65 million years ago to the present day, and cooled sufficiently so that in the last 2.7 million years, we've had what are called the late Cenozoic glacial ages, which is a sequence of glaciations which we're now in. Last glacial maximum was 18,000 years ago. We are actually now more or less at the height of an interglacial. We would be going back into a glaciation. It's a sawtooth pattern, by the way. You come out of glaciations very quickly. It takes about 10,000 years. It takes about 100,000 years to go back into a glaciation. So at this point in the normal cycle of the late Cenozoic, we would be going back into a glaciation, but we have been putting carbon dioxide into the atmosphere for the past 300 years. But I'm in total agreement with Robert, for example, that this is nothing to worry about. The natural variation in the Cenozoic might be 100 parts per million, but the natural variation in the history of the geological record is several thousand parts per million. And as I've already pointed out, the dinosaurs were extremely happy under regimes of much higher carbon dioxide than we have. And what's more, early mammals were very much alive at times of higher carbon dioxide than we have today. What we actually do have is a media-generated problem, which is about selling newspapers and books. And we're all going to die because carbon dioxide levels are rising. And one of the consequences of increased carbon dioxide in the atmosphere is raised sea level. Estimates of the melting of the West Antarctic ice sheet and Greenland put sea level rise of up to 70 metres. 70 metres, given that most of our cities are on the coast, is generally regarded as bad news. But I personally have a great deal of faith in the ingenuity of the human race to cope with increased carbon dioxide. And I'm not necessarily talking about geoengineering. But the biggest problem we have is that there are 7 billion people on this planet, and an awful lot of them live on low ground. So clearly somebody's going to be doing quite a lot of dying unless we can get our head around how to mitigate the effects. But I personally have no doubt that carbon dioxide change is a permanent feature of the climate system on this planet. That is why there is a discipline called palaeontology. And I think there's nothing to be served by wailing, running around, tearing our hair out, except of course that it does mean that a lot of people who are funded by the Natural Environment Research Council and other people are also getting fat grants to maintain this media-driven status quo of hysteria. I think that's my position.
Media-driven status quo hysteria. Does that count as something you know about theatre, or is that an opinion about it?
Well, I don't know. Shall we have a show of hands? Who thinks that there's a media-generated system of hysteria around the CO2 debate? There, I think that's your answer.
I think I would agree with that. I mean, the politics is horribly polarised and horribly pent up. And can I just clarify a technical point? In the pre-Cambrian, the sun was, I think, about 5% cooler. It was definitely a lot cooler, and that's very hard knowledge from solar modelling that even checked with the neutrino flux. So you can't just do a one-to-one comparison there. We really needed more CO2 to keep the planet from being a snowball Earth in those times.
China was a snowball Earth.
It was a pre-Cambrian.
So we're just going to rewind that a little bit, because you're going to go into this. I actually wrote a book about snowball Earth, so I'm very tempted to go with you. But we need to rewind to talk about why we're discussing this and why it matters. Exactly. So the point here is that it's absolutely, we're all apparently agreeing that CO2 definitely has varied very dramatically over geological history. The Earth has been around for about 4.5 billion years, and for most of that time, CO2 has varied very wildly. And that's one of the reasons that we can establish that it does have this relationship with temperature. So that's something we're apparently agreeing on. And then also there were times in the past when apparently CO2 was wildly high. I mean, really high, vastly higher than we were imagining. And then again, that's something else that we're all agreeing on. And it's difficult, and one of the best ways to look at what might happen now and in the future is to look at the way that the climate's changed in the past. It's the only experiment we've got. We can't do an experiment on another planet and see what happens if you do this or that, so we have to look at our own. And so there's a lot of weight around the idea that the past could be the key to the future, but on the other hand, the past was different, it was another country, and so on. So that's why we're talking about this now. The sun has actually been getting warmer as it grows older. So in times in the past, the sun was cooler, there might have been more CO2, but that's not quite exactly equivalent. But there's just one other thing that I wanted to point out before we go back into this, which is that, Bob, you talked about CO2 as being an environmental benefit. And I think I'd like to say that sounds like an opinion. We're trying to say, what do we know about carbon dioxide? But I'm actually, perhaps surprisingly, going to put that under the list of facts, of things that we know about carbon
I'm happy to
dioxide.
have it classified as an opinion, but I gave you 3 facts.
I would like
on
to.
which the opinion was based.
I would like to put it under the category of facts. I might take issue with you about some of the reasons that you gave, but here's one that I'd like to, which is that you were just talking about how if we hadn't had that much CO2 in the pre-Cambrian, the world would have been a snowball Earth. The world would have been completely covered with ice and snow, and almost all life would have been extinguished. And that actually happened several times in Earth's history. It was the biggest global catastrophe, you could argue, that the world's ever encountered. So there is an important point that we're actually slightly on the edge. We talk about Earth as being a Goldilocks planet, which is just about the right distance from the sun to be very comfortable. Venus is closer, it's way too hot. Mars is farther away, it's way too cold, but we're the just right planet. But in fact, we're a bit too far away. And if we didn't have carbon dioxide and other greenhouse gases in the atmosphere, the Earth would be frozen. And so, unquestionably, some amount of CO2 is an environmental benefit to the Earth. If it were not for CO2, there would be no life on Earth. Michael?
I would agree with all that, and I'd say actually we're perfect Goldilocks because you need some CO2 and the things are regulated on various timescales in order to have a thermostat keeping the planet habitable. If you went too close to the sun, we would be like Venus almost certainly. Can I just ask that, do we all agree on the following point, that thanks to the amplifier effect, the sea level is almost certain to rise substantially in the coming decades and centuries?
Yes.
Or would you agree? I think.
Do you want to take that on there? Yes and no. Sea level was rising quite steadily prior to industrial levels of carbon dioxide emissions. There are 2 camps using 2 different instruments. One uses satellite measurements, which are modern and I would say still experimental and not fully verified, and others use the traditional method of tide gauges. And depending upon which of those 2 numbers you get about 1 millimetre a year or 1.5 millimetres a year from the tide gauges, and you get 3 millimetres a year from the satellite measurements. Now, that's between 15 and 30 centimetres a century. And in the last century, 20th century, we had about 18 in that range. It was about 18 centimetres of sea level rise. Most places around the world didn't notice because that 18 centimetres is very small compared with the range of natural variability in the intertidal zone caused by tides, caused by waves and all the rest of it.
So just in the future,
So in the future you can calculate 2 ways. You can either just project, this is a naive projection, what's happened in the last 100 years, in which case sea level will rise about another 18, 20 in round 20 centimetres, or you can plug it into one of the computer models that Michael is so proud of.
No, I'm not.
he said that the computer models went up for the job.
And that will give you a higher number, and depending upon the computer model, it can be anything between, it overlaps at the bottom end with the tide gauge, 20 centimetres. The top end, it can be as much as 1 metre, 1.5 metres, or Jim Hansen even 7 metres.
Over the next
100 years.
I agree that current measurements leave the point a bit ambiguous. I'm arguing a different way. I'm saying the insight into the nature of the system makes a strong prediction that sooner or later the sea is going to rise a lot more. That's not depending on the computer models at all. They don't even do the carbon cycle correctly. I'm saying it's the system's insight and the insight from palaeontology and the insight into the properties of CO2, which is the chemically most stable, non-condensing greenhouse gas.
So in an equilibrium with large amounts of CO2, you melt large parts of Greenland and Antarctica, and so you get a different kind of pattern in sea level rise than the one we've seen over the last 100 years.
You also heat the ocean, which expands. So yes, of course, there's a sea level rise. Again, as with the temperature effect of carbon dioxide in the atmosphere, that's not the issue. The issue is how much.
Yeah, Absolutely. So we know that, but we don't know how much. Richard, did you have something you wanted to ask?
In the late Cretaceous, when carbon dioxide levels were 8 times higher than they are today, the whole of central North America was under an ocean called the Western Interior Seaway. The shoreline was in Wyoming to the west, and on the east it was close to the Appalachians. Dinosaurs had a very happy time in Wyoming, which is on the shore of this ocean. That's why there's so many dinosaur fossils in Wyoming. If you melt all of the ice caps today, sea level will rise by 70 plus meters. Okay? This is all about time and time scale. And the problem here is that people get confused between the two. The days of our years are 70, if we're lucky. Nowadays with modern medicine, 100. This planet's 4,500 million years old. Dinosaurs became extinct 65 million years ago. Earth's orbital geometry around the Sun, the so-called molecular parameters, control the succession of ice ages through the modulation imposed by carbon dioxide.
To sea level.
And from there to sea level. Sea level has risen and fallen. In the Pleistocene, you can tell this by looking at coral terraces in the Indonesian peninsula if you want.
Is it pacemaker?
Do you mind not interrupting me?
Pacemaker?
What I'm saying is that carbon dioxide varies on timescales, and our timescales of what we perceive are not necessarily the timescales on which these things operate. And it's that disjunction which gives rise to misinterpretation. For example, at the Paleocene boundary 55 million years ago, methane, which by the way is a significant greenhouse gas, outgassed from the continental shelves and went into the atmosphere, caused global warming, took about 20,000 years for this to happen, took about 100,000 years for it to go away. Okay? So that's, we're talking about 120,000 years for a very brief CH4 and CO2 spike to come and go. You get an awful lot of human generations into 120,000 years. So what I'm saying is that, you are being bamboozled by people who are fooling around with timescales, confusing human timescales with geological timescales, and the two are not compatible.
So are you saying here that we shouldn't actually worry because the timescale will be too long?
No, I'm saying that climate change is a natural part of the Earth system, and worrying either way is irrelevant.
Okay. So Michael, what did you want to say?
Well, I just wanted, sorry Richard, you said that Milankovitch parameters of Earth's orbit control the climate. I would rather say they're a pacemaker. Would you agree, really?
Yes,
Had a small effect into this amplifier that's tending to like a synchronizing mechanism. And of course...
So let's not, I'm worried that's a little bit technical, but there's a bigger question.
But I think the thing I was trying to get clear, I think, Richard, you and I agree on that the upcoming changes are likely to be pretty big, including the sea level rise, and your position, and I think it's quite close to mine, is that we shouldn't worry, we should just accept that this is going to happen and prepare to adapt for it, to rebuild our coastal megacities and all of that, but we'll have quite a lot of time to do it. Is that a fair summary?
It's a summary. My position is that I think it's horrendously arrogant to think that the climate is going to stay as it was, which allowed the evolution of a bunch of naked, big-brained apes. It never has in the past. Why should it now?
So moving directly on from that one to this question about apocalyptic thinking, so that really is what we're all talking about here is you said right at the very beginning, Michael, that this is not the end of life on Earth or even humans. You said instead you think it's a huge business opportunity. So I'd like to ask each of you to comment on this. To what extent do you feel that there is apocalyptic thinking, that is helping or hindering the question?
Oh yes, I mean I've thought about human evolution and psychology quite a lot, as you'll see from tomorrow's talk too. And there is, I think, in our genetic memory, these, well, let's be careful how we say this, the self-assembling elements of an instinct for apocalyptic thinking. You see it in the book of Revelation, and all the other drafts that got rejected. It's in all the great cultures and religions, because there's just an urge to say the end of the world is nigh, and this is operating, I'm afraid, in the media hysteria, and I deplore it. I'd like to be a dispassionate scientist.
The question in the preliminary notes was, is apocalyptic thinking confusing science? And my answer to that is no, but it is confusing the general public, policymakers and politicians, and this is the point that Richard has made. However, there are three things that are confusing the science, and they're the following. Firstly, the constant misstatement of the problem. All of the three of us on stage are used to being asked, is global warming still happening, or do you believe in global warming? Now, the first answer, if you're a scientist, is I don't believe in anything. It's not a matter of belief. But more to the point, that question is code for, do you think that dangerous global warming is occurring caused by human carbon dioxide emissions? That's a very different, specific, testable proposition. And that's what the reporter or the news editor means when he conveys to the public about global warming. And because the scientific detail isn't spelled out, the end result is confusion, because global warming is always happening over geological time periods. It gets a bit warmer, it gets a bit cooler. So it's a perfectly natural part of the Earth system. What we're worried about is dangerous global warming. And I know that you can argue about what's dangerous, but let's do that. And the cause is you having bought a second SUV. That's the problem. Secondly, there's the deliberate... well, perhaps you have two SUVs. Secondly, there's the deliberate imprecision of language. And even prime ministers and premiers talk about carbon. This has nothing to do with carbon. You don't talk about London's water supply in terms of hydrogen. It's about carbon dioxide. Okay? So, and that's just one example. Dirty energy is another one. The whole language of discussion of this issue is riven with deliberate ambiguity and imprecision from a scientific point of view. And the third problem is the inversion of the null hypothesis. The null hypothesis for a scientist is the simplest interpretation of a set of facts. We know climate varies naturally all the time on all time scales. Therefore, the simplest interpretation of the gentle warming we observed, and we did observe in the late 20th century, is that it is natural. That's the null hypothesis until you can provide evidence otherwise. Unfortunately, the whole IPCC official advice industry to politicians is based on the reverse of that null hypothesis. It is that warming was caused by humans until you, Bob Carter, can prove otherwise. That's a complete inversion of usual scientific method. So there are problems.
Okay, so interesting points there. And I think you talked about the advice industry. I'd like maybe to come back to that if we have a moment to. But what I wanted to ask you there is, and in fact this is a question for all of you, you're saying that we don't know it's dangerous. Let's talk about whether it's dangerous. You're saying that we can expect that changes are natural until we have some reason to believe otherwise. But we've also all said that we know that higher CO2 tends to go with higher temperatures, that it is a greenhouse gas and it's likely to cause warming. And we also know that it's higher now than at least for the last 800,000 years. So for long before humans came onto the planet, it's very much higher now than it has been. So those are all the facts, right? So there are going to be changes, and there's probably going to be more changes than if we hadn't burned the CO2, but we don't know what that is. So are you now saying that the best next step is just to see what happens and adapt to it? Or do you think we should be taking any measures at all to reduce the amount of CO2 that we're putting out?
Yeah. Well, there's lots of things here. The first thing I want to do is to defend the oil companies. I mean, the oil companies are routinely put up as bogeymen. Now, I consult for an oil company, and I can tell you that they are very interested in the problem of CO2 and the related problem of ocean acidification, which we haven't talked about. The higher the carbon dioxide in the atmosphere, the more acid the oceans get, and so you end up with a decarbonation of the Great Barrier Reef. Now, I can tell you that oil companies, I mean, I don't know whether Exxon's an exception or not, but the one I work for, are very interested in investing in alternative technologies for the very simple reason that you make bigger profits if you keep your customers happy. And so, the next time somebody rolls out any oil company as the ultimate bogeyman, remember that this is an agenda which has actually got nothing to do with carbon dioxide. Yes, I mean, sea levels are going to rise, but to be honest, I'm more worried about whether or not North Korea is going to fire a nuclear weapon at Japan. The bigger problem than carbon dioxide is the overpopulation of the Earth, I think. There's too many of us competing for too few resources. And if we could get a handle on that, which means politicians and indeed societies starting to be grown up and talking to each other as opposed to just killing each other, then we'd be starting on the way to solving the overpopulation problem and, of course, the carbon dioxide problem.
So specifically, though, do you think we should be doing anything else to reduce the amount of emissions we're creating? Should we just bed down and wait to see what happens?
Well, in the grand scheme of things, the amount of carbon dioxide that we're putting into the atmosphere is pretty trivial compared to the amount of carbon dioxide that the ocean in the past 3.8 billion years has shoved in and out of the
Humans
atmosphere.
haven't been around then. So, I mean, you said actually somebody's going to do quite a lot of dying.
That's true, but that's really a function of the overpopulation, isn't it? 7 billion people, most of them on the coast.
So should we try and do something about that, or do you think we should just bed down and wait?
I think it would be nice to try and do something about it.
Michael?
I just want to clarify a point. The amount that we shove in and out of the ocean over the Pleistocene ice ages is that 100 parts per billion in the atmosphere. There's a lot of agreement that the terrestrial biosphere is a smaller contribution. So if we put several times that, you know, it is, I would argue, substantial. But, okay, what is dangerous? You're asking what is dangerous? Well, that's a matter of opinion, isn't it? That's a political question. Is the inundation of the London and other low-lying cities dangerous or not? I mean, I expect that will happen and that people will adapt and smart people will make money out of it.
Richard Branson, for example.
Yeah, including Richard Branson.
But the specific question was, should we actually do anything to reduce the amount of CO2, or should we just bed down and adapt to it?
As I said, I can't do politics. I have really no idea what to do apart from, I think it does make sense to encourage alternative energy technologies. Some of them are quite good, some of them increase our energy security for one thing. And so I would have thought that it should be on our political and economic agenda to encourage those things and see what happens, because the really smart technologies that may make a difference in the future probably haven't been invented yet.
Well, I come from Australia, and in Australia, the biggest natural hazards are bushfires, droughts, and floods. I used to live in New Zealand, and when I say biggest natural hazards, I mean the most likely to produce catastrophic loss of life and huge costs. Now, when I lived in New Zealand, the big risks were volcanoes and earthquakes, which are a virtually almost non-existent risk in Australia. These are normal environmental hazards, and a lot of them aren't climate related or weather related. Okay, obviously any government has a duty of care to its people. After defending the borders, the next, probably most sacred duty is not to balance the budget, but to protect the people against natural hazard. Therefore, it's a total no-brainer that governments have a responsibility for having a policy that is adaptive, which is what you were asking, to hazardous natural events. Now, if you do that, you do not have to worry about what's the cause of it. We know from the natural variation of ordinary climate and weather events that we have a lot of planning to do, and we have crisis emergency response squads and so on. And if, and it's a big if, there is then a further impact from human-caused global warming, that is dealt with in exactly the same way. So adaptation is essential, and the main reason is we don't know. No scientist on the planet can tell you whether it will be warmer than today or cooler than today in 2020, just 10 years ago.
So just
So we prepare for both.
I think I absolutely agree, and I also think that not enough has been said about adaptation. I'm very happy that that's been such a big part of this conversation. But I also think that there are some interesting aspects of the whole question, not just do we go for alternative energies, but how do we handle the energy system that we have. So if you look at the amount of energy that's coming out of the primary system and how much is finally delivered to be useful energy, the figures are something like 470 exajoules. So you start with the primary energy and it goes down to something like 45 or 50. So a vast amount of wastage from 470, and you start pulling it all out and creating it, to 45 by the time you actually use it. And similarly, if you look at the amount of food that's wasted around the world, on average, I think 40% between fields and bay. And if you look at the amount of water that's wasted. So we actually, and nature doesn't waste. Not because nature is noble, but because nature isn't stupid. And because wasteful organisms tend to go out of business. So I think one part of this story is we have evolved a system where we're wasting our resources because we can, and in the process we're creating, the first one to bite us is starting to be CO2, but there's going to be plenty others if we have 7 billion people on the planet and we do this kind of wastage. So that would be one comment that I would like to make about what we could perhaps do next. But I hope that might have provoked some thinking and some ideas among you. So let's now move to some questions. There's one over there.
Hi, I'm a consultant. Part of my job is helping cities in developing countries develop adaptation plans for climate change. And I gotta admit, I'm pretty almost upset by the cavalier sort of approach of the panel towards life of the people in developing countries. The idea that we can just build walls around all these cities where billions of people are living and just protect them against climate change, they can't afford it. It's not true. There'll be millions who die. And you're saying about the noble principle. I would say it's a precautionary principle. It's not that, well, we don't know they're all going to die, so let's not worry about it. If this might happen as a result of our activity, surely it's our moral obligation to do the best we can to stop it. And the fact that the dinosaurs survived with lots of CO2, I don't see why that's all relevant. It's a completely different society, we're a completely different organism. Huge parts of the human race will be at direct threat, and potentially it's not, and there is obviously a natural cycle in the background, but potentially what's going to happen in the next 100 years and the billions of people that's going to impact is directly driven potentially by our activity. Now, is that alone not sufficient reason to devote to 1% of our GDP at a certain stage? It's probably wrong, it's more like 3%. I just can't see how you can be so cavalier about.
Okay. So it's a bit of a challenging question. Is it just being are we just being cavalier? This is a philosophical debate, but this is actually about real people and real people's lives. And those are people who can't actually afford perhaps to adapt, but are the least responsible. If any part of this is human cause, they're the ones that are least responsible for solving it. Richard?
Yeah, if you're talking about moral obligations, I think, personally, I'm not going to discuss morality or ethics because I'm a scientist, and morality and ethics are my business, my morality and ethics. But what I would say is that there are technologies downstream which are not just carbon neutral, they're actually carbon negative. There are ways of consuming carbon dioxide and generating energy. And I totally respect your position that you feel that people should be protected from the effects of climate change, and I can tell you that is going to happen. What I would also say is that this problem is only about 300 years old. Bob has very eloquently put the case for ice ages and mini ice ages and the younger dryas and all the rest of it. And if you think about the way technological evolution has accelerated even in the last 50 years, you think it's down the road, I'm pretty confident that we will find a solution to consuming carbon dioxide. But as for the morality and ethics of it, and I entirely agree that is your opinion, and I respect it, but personally I'm just speaking as a scientist.
Anyone else want to comment?
Well, I'm devastated to learn that I'm cavalier. I was only trying to get the science clear. Of course, as a person, my heart aches for all these millions of people who are going to be probably inundated. Unless we're very clever about adapting and moving them to higher ground, perhaps cutting down on carbon emissions. I think it's too late to cut down on carbon emissions enough to stop the sea coming up. So it will be a question of adaptation. And I didn't know about these carbon negative technologies. There you are, smart technologies may come in. That's exciting.
Can I just pick up Richard's point, which is, I think much of your question was predicated on what I would call politics, or if you like, morality, whereas when I make my comments about null hypothesis, I'm talking about scientific method, and that's a totally different thing. In terms of the problem you perceive, I'd just like you to think about this. You don't need to respond to it. one of the effects of the huge political pressure to cut carbon dioxide emissions is to try to stop the construction of coal-fired power stations. The World Bank has considered not giving, in fact I think they did not give a loan to South Africa to build a large new power station on the basis of this is harmful for the environment because of the CO2. Now, what is the best way out of poverty for a third world nation? It is development and cheap energy. And the West, through its incessant pressure on undeveloped countries not to build coal-fired power stations, is denying them the very best method to improve their lot.
I would challenge that actually. I'm just been in Beijing, and the Chinese government is now trying to retrench from coal-fired power stations, not because anyone's telling them to, but because nobody can breathe. So,
This is sulfur
let's just bear that in mind. It's nothing to do with carbon dioxide, but it is generally that point. You can't just say this one technology is perfect for the developing world and you mustn't stop them doing it. What you can do is you can say, let's see how we can leapfrog. So we can actually get to cleaner technologies that don't make people choke and don't cause more CO2, but can still enable development. Yes, here. And then, sorry, the lady over there. Here first, and then the lady.
I'd just like to comment first on the fire station idea. I've been to Drax, and I have been absolutely horrified that they've secured 4,000 square miles of forest in America. They're building 2 wood pelleting plants. They're going to ship these wood pellets over to here, just to burn them instead of coal. I think it's insane myself, but it's all to do with subsidies and government restrictions. I have 2 questions. One is that I'm quite confused about what proportion of global CO2 is man-made and what is natural. I mean, I've heard a figure that we only produce 4% of global CO2. And the other question is not the greatest danger from maverick geoengineering policies in engineering?
So 2 good questions. One is, I'll give it to Michael first for the question of what proportion, but I like to reserve the right to add a word too. So.
Bob was saying we're fraught with ambiguity, 4% of what? I mean, I tried to say it more clearly. If we put enough in, and this is mostly from human activities, an amount that's comparable to the natural range of variation. That's 100% by a natural measure.
Yeah, so if you think about it, at the moment we have 400. The figure is 400, it doesn't really matter what the units are. And before we began burning coal, oil and gas and chopping down forests in significant amounts, we had 280. So you could say that 120 units out of 400 have come from humans. But if you look at the amount that's put in every year, and if you look at the vast amount that's put in from the biosphere every year, you get a different figure. And then the way I like to think of this is it's like a bath. If you're running a bath, and you have the tap on and you have the plug, so you can put a lot of water through that, the water's going out of the plug, in from the tap, out of the plug, still stays the same level. So you can get a lot of throughput in a year because you're putting CO2 out from the biosphere, you're taking it back in again, putting it out. If you just add 1 bucket full of that, up to that, it can be quite small compared to the total amount that's going through all that time, but it can still be enough to make it spill over. So that's just another interesting way to think about the differences. For the second point?
Are we not a greater danger?
Yeah, from a maverick geoengineer. Who would like to take that?
Richard
What's a maverick geoengineer? I mean, I know what a geoengineer is.
Somebody from James Bond, I think, one of those.
Flooding the aliens with iron filings.
Yeah, adding iron to the Southern Ocean. Yes, I mean, good idea.
Satellites.
It could be a good idea, but then what if it goes horribly wrong? We don't have a terrific record of getting things right even on our best intentions. So.
Well, I mean, that's what you do in experiment first, isn't it?
I mean, it is. Michael already spoke about the ozone layer. I wrote about this in a previous talk, and the guy who invented the chemicals that nearly destroyed the ozone layer was a wonderful, very inventive guy who was trying to help. He was actually trying to make things better. He was trying to make a chemical that's completely inert and wouldn't cause any problems to anybody. He wanted a refrigerant. It was fantastic to have it in fridges, and this was so inert it wouldn't poison anyone, it wouldn't choke anyone. It's fantastic, and nearly accidentally destroyed all life on Earth. So, but we don't have a fantastic record, and that's what will make me worried about some geoengineering.
I got confused about the water level rise. seem to vary from 20 centimetres a year to 70 metres sometime in the future. But I can't set that into any kind of framework that relates to my lifetime or my children's lifetime.
And I think that's a very, very good point to raise, Michael.
Just simply, I was referring to the past big changes in climate accompanied by the 100 parts per million change in atmospheric CO2. The sea went up and down by more than 100 metres each time. Nature repeated that experiment several times. So the 100 metres is, and by the way, that's the sort of amount you get when you melt a large portion of the great, or you build up the great ice sheets rather, you build them up in the ice ages. If you melt everything now, which I would argue is highly probable within a few thousand years, then the sea will come up by the figure of 70 metres, several hundred feet.
And it's not like, sorry, Michael.
Please, no, that's one.
It's not like it hasn't happened before. In the Cretaceous, which I've talked about, there were no ice caps, and there was a sea which, curiously enough, inundated the whole of the American Bible Belt, which some people might think is not necessarily a bad idea. That's what the Western Interior Seaway was. But that's a time of no ice sheets, sea level 70 to 100 metres higher. It won't happen in your lifetime, simply and easily.
But over 100 to 200 years, what's the range that we're looking
A couple of metres.
That's where the models aren't good enough, though, but it could be substantial. That's a good guess, a couple of metres.
One comment on sea level. Everything that you hear in the public discussion and implicit in your question and all the answers is this is global average sea level. If you live on, where I live on Great Barrier Reef, coast of Australia, global average sea level is irrelevant. What we're about is local coastal defence based upon measured local sea levels. And if the global average is, let's say, 1.5 millimetres per year rise, there are some places in the world where modern sea level is actually falling. There are others that are rising at 5 or 6 millimetres per year. It's horses for courses. That is part of the deliberate ambiguity of language that I spoke of earlier in this debate.
Okay, just very briefly, Michael.
But if it were up by 2 metres, then actually you would notice it globally.
Yeah, and just one point to add to that is that it is one of the key features when we say what do we know and what do we not know. It can be important to look at the possible range in the precautionary principle that we were discussing.
In the context of global sea level on the one hand and local sea level, which is going to affect your shoreline cottage on the other.
Absolutely. So we're actually coming to an end here, I'm sorry to say, so I'm afraid we don't quite have time for any more questions, although there will be opportunity to speak to the speakers afterwards. But I would just like to go back to everybody for just one very brief comment. We had the question of what do we know and what do we not know and what should we be doing about it. So in the light of this discussion and some of the questions we've had, Richard, just a very brief comment.
Move towards carbon neutral and carbon negative technologies, accept the fact that climate change is a natural part of this planet's variability.
Okay.
Michael made a really interesting metaphor for the climate system. I'd like to give you another metaphor to think about, which is the climate system is like a jumbo jet. And the main source of power in the climate system is the sun, which is equivalent to the jumbo jet's engines. The effects of changes in atmospheric carbon dioxide of the sort of small amount of doubling or halving or tripling is equivalent to you sitting in your passenger seat and adjusting that little nozzle above you for your immediate environment.
I once flew a jumbo jet in the days before hijacking. The captain let me handle the controls. And by the tiniest touch on the control column, I could change substantially the direction of that giant aircraft. That's what I mean by amplification.
And not just by amplification, but in fact, if we make a very small adjustment to the way that we live now, we can make a very radical difference to the way that people can live in the future. So with that, with no further ado, I'm going to add my own little two-pence. This is my right, sitting in this lovely chair. And I think I'd like to add a different kind of analogy too. If you're thinking about carbon dioxide and what we know and what we don't, I like to talk about it as like chili powder, because a small amount of it can make something very delicious, but if you put too much, it can be very unpalatable for humans to taste. And I think part of what we've been talking about is how much of the earth care, how much of the planet care, how much of life care. And in fact, that's not really the right question, because as we've already established, many creatures have lived under conditions of much higher CO2. I'm going to give you a very quick demonstration of how long the Earth's been around and how long we've been around. So this is the whole history of the Earth. This is the beginning, when the Earth was formed, and this is the end, which is now. And we've had life all the way from about here, all the way along here, all the way along here, first complex life here, first dinosaurs about here. You take a nail file and you scrape it on my finger, and that wipes out all of human history. So that's just to give a little bit of perspective. But within all that human history is all the grace, and all the poetry, and all the philosophy, and all the music, and all the creativity, and all the ideas that make humans. So I would say that humans are the ones at risk, because we now have 7 billion of us on the planet, and we have created that system on the basis of a very precise set of climate. Water, food, energy, life, temperature, sea level rise, our cities, everything has been predicated on one condition. And now we're changing it. So I would say that for many of my best friends who are humans, it's probably worth thinking about and thinking what we can do. And on that final note, thank you very much. And just to mention, oh, how lovely sunflowers. Perfect for this talk, sunflowers. Thank you.